Building robust process automation requires an ecosystem engineered for pure resilience. GlassLinq solves the brittle nature of dynamic applications and network dropouts through a stateful, industrial-grade robotic process automation platform. Configured across a three-tier architecture, it bridges high-level visual design down to native, low-level execution. At the apex sits the design and management layer, anchored by the GlassLinq Design Studio, the UIExplorer, and the orchestration hub engine. The Studio and UIExplorer utilize a WPF and Blazor desktop framework, providing developers with a low-code canvas to sequence tasks into compiled XAML workflows and a dedicated utility to spy on elements, dissect interface trees, and tune selectors. Connected to these tools is the orchestration hub. Powered by ASP.NET Core SignalR, it establishes immediate, bidirectional WebSocket connections to manage machine grouping topologies and handle dynamic real-time task dispatching. Dispatched jobs travel down this WebSocket pipeline into the distributed agent runtime layer. On the deployment machine, a runtime agent daemon operates continuously as a .NET generic host background service, managing host environment fingerprinting and resilient network reconnect ion loops. Once a command is intercepted, the agent instantly spins up a custom workflow execution engine. Utilizing .NET XAML services, this engine deserializes the workflows into an isolated state machine activity, tracking lifecycle state transitions, catching system exceptions, and enforcing strict iteration loop safeguards to prevent host CPU lockups. The runtime communicates with target applications through the low-level execution layer, splitting tasks into distinct web and desktop pipelines. For desktop automation, the engine utilizes the native Microsoft UI automation framework to access the OS accessibility tree, allowing the bot to interact directly with native Windows elements, WPF apps, WinForms, and enterprise software. To handle web applications and eliminate string corruption bugs common in console streams, the engine routes requests through a low-level messaging bridge built on asynchronous C# named pipes and standard I/O, which processes strict 32-bit little-endian length prefixed binary frames. These frames feed into a Manifest v3 browser extension router that handles tab context tracking, window focus isolation, and manages background worker keep-alive heartbeats to prevent Chromium from idling out. The web pipeline terminates inside the web page's live DOM via an in-page UI injector built on vanilla JavaScript, firing precise, native-level click and typing instructions. During design time, both the in-page injector and the native Windows UIA hooks pair with the desktop UIExplorer app. The Explorer parses the target elements, automatically scanning surrounding visual coordinates to dynamically map resilient, proximity-based UI anchors using high-fidelity XML target tags. This selector metadata loops straight back into the desktop design studio to close the development lifecycle. With all of these components unified into a single, cohesive ecosystem, GlassLinq bridges the gap between high-level visual design and resilient execution. We have decoupled our workflows, built native hooks directly into the Windows operating system via UI automation, and bypassed traditional browser isolation using high-speed binary streams. This isn't just a collection of disconnected scripts or brittle web scrapers. This is an integrated, industrial-grade automation engine built from the ground up to provide maximum reliability, deep selector insight, and centralized control. This is GlassLinq, the future of resilient enterprise automation.